Welcome to the Prosthetics and Orthotics podcast with Brent Wright and Joris. Hello, everyone. My name is Joris, and this is another episode of the Prosthetics and Orthotics podcast with, of course, Brent Wright. Hi, Brent. How are you doing?
Hey, Joris. It's good to hear from you, man. I'm really looking forward to this episode.
Okay. So, Brent, tell us a little bit about who we have today. Who we got on?
Yeah, today we have Jeff Erenstone, and I would say Jeff is one of the first people that saw how 3D printing can impact O&P. And so I'm really excited to kind of hear his journey. I don't know all of it, but I do know that he is a huge advocate for clinicians being involved in the process of creating a prosthesis. But also he has his pulse on a lot of things, not only on the kind of the political side of things, but on the technical side of things. And he is, I don't know if all-knowing is quite the way to go, Jeff, but that's he has his pulse on a lot of things, not only O&P, but 3D printing. So really excited to dive into that.
I would say that I may have known things, but I forgot more than I remember. Well, thank you for the introduction. I'm excited to be here and talk with you guys. You know, O&P has definitely been something I've been involved with for a few years here, and I'm one of those many people, I guess, who have the story of that. I was thinking about physical therapy school, and looking. I was actually working as an aide, trying to get experience before going to physical therapy school. But the facility that I was working with, they had a little foot orthotics lab that they made, foot orthotics on site. And I just sort of became the guy to make the foot orthotics. And then after a little while, I kind of wow, I kind of like this. I get to, do all the patient care stuff that I enjoy doing, but then I get to go in the back and, build things and make things. And steadily realized that there was a whole field that kind of merges those two things, the O&P field. And from that point on, I've been hooked and, have my own clinical practice up here in northern New York, Mountain Orthotics and Prosthetics. I've had a couple startup companies, that I've gotten involved with and then, exited from. And but now I'm greatly involved with developing world care, nonprofit type work, as well as working with some of the associations, probably mostly with AOPA.
Okay, so first, let's start about how you got started with the digital starters things. I mean, when did you first realize that aside from the hands-on O&P stuff, there's also this whole digital world out there?
Yeah, so when I established my practice up here, I'm in Lake Placid, New York, and I'm not sure if you know that there's kind of an Olympic heritage here in Lake Placid. We had the Winter Olympics in 1932 and also 1980. And for that reason, there's also an Olympic training center here. One of the 3 Olympic training centers in the country is right down the street. And so part of the reason I settled here was because I wanted to get involved with adaptive sports, Paralympic sports. And so, that kind of started taking off, and I was doing a lot of, one-off designs, specifically for these adaptive athletes. And, probably in the, early 2010s area, let's say, just sort of found that, 3D printing was being really helpful. I mean, before that, I'd get a lot of CNC, milling done. Well, generally that would take a lot of work with design, and then, send it off to someone to have to rework the design so that it, could be millable. And, it was a big back and forth, and, generally a part would take about 6 months or something like that to get back into my hands. And then, discovered, some of the earlier 3D printing that was out there. At that point, mostly working with, design houses and stuff like that. And they, the turnaround time became, 2-3 weeks to get my part back. And, obviously much better than 6 months. So I was really appreciating the iterative design, let's say the prototyping, the speed up of the prototyping that I was able to do on those adaptive sport designs. And after that, kind of decided to get my own printer. And found that, that 2 or 3 week turnaround turned to a day. I designed something in the morning and have the part in my hand. And so just through that prototyping process, I got very, very excited about 3D printing and what it could do for the custom designs that we, have to do very regularly in our field.
Okay, and then what kind of printer did you get initially?
Let's see. I think the first one I got, it was a Printer Bot Simple. That was the first one. Yeah, I had kind of a long series of Printer Bot printers for a while there. The Simple, the Plus, and several more.
Okay, I love those things. Those are they're adorable, first off, and they work really well. They're really long-lasting, kind of throw anything at them, a device. But the Printer Bot seems like it could be the build volume's really small for a lot of the stuff you were doing.
Yeah. I mean, I honestly took, the Printer Bot Plus that, I had and kind of figured out that I could make it taller. And that was sort of my first hacked printer. So, I made that taller. And then I guess my next kind of, work with printers and kind of hacking them was, oh gosh, I can't think the Flash Forge, I think it was. It was sort of a MakerBot remake. Like a clone of MakerBot.
Tribute.
There we go. A MakerBot tribute. I like it. So, I figured that was pretty. Actually worked with a friend of mine, and we kind of hacked that one as well, and we were able to get that thing up into it was printing 400 millimeters tall, and that's when we started doing covers. I actually printed covers on those machines for years. We had like 3 or 4 of them that were hacked like that. We printed cosmetic covers for years on them.
Okay, and that was just using. You just use PLA then, or what did you use?
No, I early on I got pretty excited about the TPUs out there, and in part because I got to know incredible individual named Steve Wood. He's an engineer.
I know that guy. The English guy, right? The Gyrobot.
Gyrobot, you got it. Yeah.
I love that guy.
Absolutely. He's just, he's a Renaissance man. He's just amazing at so many different things. I think at that point in time, he was working on like nuclear fission reactors as his day job. Designing, prosthetic parts on the side. He was involved with Enable. I sort of got involved with Enable somewhat almost on a, I don't want to say this. Early on, there were some videos of people saying, well, hey, this $50, hand is as good as a $42,000, myoelectric prosthetic arm. And I was sort of the first person to reach out to John Scholl, the kind of the founder of Enable, and say, yeah, no, it's not. Let's we need to start clarifying some things here. You can't compare a body-powered partial hand device to a transradial myoelectric arm. Those are just completely different things. And actually part of my tactic at that point in time was to say, hey, you know what? I just made like an M Fingers body-powered partial hand for a patient. I charged $8,000, for this device to the insurance company. Let's go toe-to-toe on that. Okay, if you want to go toe-to-toe with what you've done versus what I just did for $8,000, so we're going to stop talking about $42,000 because that's just not right. But I will happily explain to you why this cost $8,000. And I got some traction. I don't know if they totally changed their messaging, but I got to have some conversations relatively early with some people who were knowledgeable, and I would say Steve Wood is one of the most knowledgeable, and we hit it off and kind of worked very closely together for 3 years. So some of the flexi hands, I had the later versions of the flexi hands, I had a direct involvement in helping design. I mean, he did all the CAD work. I just sort of gave him inspiration on how to make them more clinically relevant.
Okay, that's cool. And then, Mabel, I still think it's a really wonderful movement. But yeah, you're right. It needed to be kind of channeled in the right direction, I think, for a long time. And I thought it was really exciting what happened. And but I'd like to rewind a little bit. You were making these sports devices, let's say, and what do I think of? Because what does that even mean? Like adaptive sports device? I think I know, but I'm not entirely sure.
Yeah, fair enough. I mean, it's just a general way to say like Paralympic style devices, but I wasn't only working with Paralympic teams, and that's sort of that you have to be in the Olympics to be a Paralympic type of thing. You know what I mean?
Uh-huh.
So for example, rock climbing. That was one of the earlier things that I developed was a rock climbing foot. I actually still sell it on my website, but it's one of those things. We just have it out there. It's a low cost version. We don't make any money off of it. We just sort of want to make sure that more climbers can get out there in the world. Amputees who want to climb, can get out there in the world.
And
But
what does a rock climbing foot? What does that even look like, or what does that have to? I can't even imagine what that would need to do. Let's say.
Yeah, exactly. So this was designed in a way more for indoor climbing. So it has sort of a flat front to it, so that you can really get onto the holds that kind of stick out of the wall. But still, you can then you can kind of swing sideways. There's kind of a concavity on the bottom of it, so it grabs onto the holds as you kind of push sideways against things. And then it more or less has a point at the back, so you can, kind of get up there and kind of, wedge it in places or lean back on it, as well as like when you go outdoor climbing, you can kind of, jam that into cracks and so forth. So it was just I got involved with the extremity games back when the extremity games were happening. And I just sort of went and talked to kind of all the climbers and asked them what they wanted in a device. And that's sort of how that came about. And then eventually TRS sort of started making something different, which I really like a lot. I like the TRS foot a lot, but people ask me like, what's the difference between yours and theirs? And I was just like, well, theirs is better. That's just, but theirs is more expensive. If you're climbing every day, that's probably the way to go. But if you're just going to climb every once in a while, mine's much less expensive.
Hey Jeff, just curious on the rock climbing stuff, and I know there's people, and I know people have come to me, and I haven't had the right answer. But from a clinical perspective, what are you looking for? Are you trying to keep people like same leg length, and then can you tell a little bit about what you would do different transfemoral versus transtibial, and how that works specifically the rock climbing world?
Yeah, so I think when it comes to transtibial, keeping the same length. Transfemoral, most people work much shorter device. Some people will mount more or less a foot right to the base of the socket. There's other people kind of add another foot or so to that, so that they can get a little bit farther. But I don't think, most people are not going full length, and almost none of them are going with a knee that would flex. It's more of a kind of a rigid device. A good friend of mine, Ronnie Dixon, he uses a knee that was designed for skiing. I can't remember it's like XT9 or something like that. But it has a certain amount of flex to it, but it doesn't bend, and that's his preference. But yeah, I mean, this is sort of one of those things that I like to talk about it. When I talk about adaptive sports in general, the real answer to that question is, it's personal preference. The only way you can figure out personal preference is just go to a climbing wall with the person and see what they want to do with the thing. Because I definitely find when working with adaptive athletes, it's a the athlete thinks so much about what they're trying to accomplish. They may not be mechanical at all, but they just spend so much time thinking about it that they probably came up with the right solution. They may not be able to articulate it, but they probably know the right solution. And you just got to get into the situation. Like I said, go to the climbing wall, and then they'll say, I just want something that does this. And then you try to recreate it. And actually that's where coming back to printing, that's where it becomes really important, because the first thing you want to do is you sort of want to make a rough prototype, something you can make relatively quickly, and so you make that and put it on them, and they utilize it, and then they say, yeah, that's nice, but I really wish it would be a little bit more like this. Well, in a printing world, you can go back to the computer quickly, read, do the updates of it, print another one, they try another one. And it's really quick and easy to go through that prototyping iterative process to kind of get to the right design.
And if we're looking about like, okay, so the climbing thing I think is fascinating, right? But I mean, are there other examples? Because there must be, like, every sport has its own challenges. And then did you make a lot of different things like that as well, or?
Yeah, I was very involved with Nordic skiing. So I did some kind of one-off commissions for individual athletes, some who have actually been in the Olympics and won medals, um, and and then also I did did some other stuff for the team that kind of like they just design a part that allows them to interchange skis easily and put them on the sit skis. Um, this is for like someone who's like a paraplegic or bilateral amputee where they don't actually ski, they sort of sit in a sit ski. So I helped design the sit skis, let's say. Also done things with bobsled and skeleton, and I've done things with rowing. That was a fun one. Setting up like a rowing knee and ankle to, so someone could do kind of like a, she used to row back in the day, and before her accident, so I was able to kind of get her back into her the form that she was used to. Done biking, the list kind of goes on and on, but those are the places where I've spent most of my time in the adaptive world.
Okay, I think that's really exciting. And do you learn a lot from that? Because I think it would be a really unique. Somebody would walk in probably because they heard it from another athlete, right? And you would build a reputation, and you would end up having a completely different engineering challenge, right? So it seems like really exciting work.
Absolutely, yeah. And the way I like to work is that I sort of steadily build the sophistication. So that kind of initial like proof of concept, sometimes I just grab a piece of foam and, throw some duct tape on it, and, kind of shape it all out and kind of come back and be like, is this what you had the idea? Or even sometimes like people grab wood and shape it out of wood and this and that, and just sort of, just get something in the semblance of what they're thinking of first, and then go back and start working on the CAD designs. And then, and after I have kind of the right morphology, then kind of work on the engineering aspects of it. So sort of steadily build up in a sophistication of the design as I go, and complexity.
And do you think that changes how you approach OMP as well? Are you like, I don't know, is there more of a wealth of possibilities because you've seen how many different devices and different kind of like ways of doing it there are out there? Or
yes, but I would also say that's come back to bite me sometimes. Because there's sometimes, you just need to sit down and think about, instead of kind of come up with the new, most creative option, you need to sit down and think about like, what's been done for, 20, 30 years, and, why has that been working? And maybe I should stay there instead of always going and trying to figure out the most, newest, most creative option. So, it becomes a nice equilibrium and figuring out what's new that hasn't been figured out because there was kind of a lack of tools in the past, but also going back and looking, what has been done, because there's been really smart people in the field for a long time, and they may have figured it out a long time ago.
Okay, all right, that makes sense. And do you think so with vis-a-vis printing? I like that you use it as a prototyping tool as fast iteration. Did you move on from printer boss to more sophisticated machines, or what kind of printers did you use after the Flash Forge and things like that?
Yeah, well, so then I started a company called Create O&P, and so at that point in time, we sort of started out the company saying like, hey, we figured out like 8 different things that you could print, and we're trying to position ourselves as having the ability to be able to teach people to do all different, all those 8 different types of devices. But kind of figured out that, man, there's a lot of, things that may be intuitive for me, kind of in the field. It's not as intuitive for somebody who's a busy practitioner who's just sort of dabbling with this technology. So we struggled to be able to teach people all those different types of devices. And so then we sort of scaled down and started specializing. So we started working more with, some upper extremity stuff, but mostly with transtibial sockets and cosmetic covers. And that's when we got to that point, we found that we really needed to start specializing the machines, to kind of answer your question. And so I actually went back to PrinterBot initially and asked them to kind of design a machine for me. And they did. And, had good successes with that. Unfortunately, that was at a time period where they were having some internal upheaval and ended up going bankrupt about 6 months after we were working with them. So it kind of, they were great to work with, but, at the end there, they had their own problems. And then eventually we had to kind of start building the machines in-house. So like I said, PrinterBot made a specialized one for us. Then we made something similar to that, and then eventually, I exited from the company, and it became PVA Med, and they have a kind of a specialized printer themselves that they're working with. Yes, in short, went from the kind of the machines the all-around machines to specialized machines. But I have to say now these days with my nonprofit work, I'm going back to all-around machines again because I sort of a different level of different goals.
I think it's interesting to ask because we talked to a bunch of people before using like Dye's design high flow nozzles. We talked to people that are designing machines that are a little bit different than the standard machines we've seen a lot of other industrial, like really quite large, quite robust type FDM type machines. And that kind of seems to work a lot with OMP as well. Is that the kind of machine, the custom machine? Is that the ideal, do you think, for a lot of OMP practitioners? Big kind of high flow machine, that kind of thing, or?
Yeah, well, I guess I get to take the credit of the first. Okay, hold on. I got to be very careful here because there's Squirt Shape. They were the first. Squirt Shape was definitely the first by far to be able to make high flow in the field. But I guess their design all happened in the 90s. It was very specific to their own workflow. We kind of in the early 2000s kind of started working with the technology that was already in the marketplace and figuring out how we could get that more specific for O&P. And so one of the things I helped design was a 3mm nozzle. And I should be careful. Carl Urbis did the design. I just sort of inspired him to do it. But anyways, the point I'm getting at is, as soon as we had like a 3mm nozzle, worked out in a high flow hot end, then we needed to kind of build a machine strong enough that could handle the extra material that you're kicking down and didn't have any flex built into it. And then the next thing we had to figure out was how do we cool it down? Because it's one thing to kick out a lot of material, but then you got to cool it down again to be able to build the next layer. But not cool down too much, because you still need to get good bonding. So that was sort of the, about the time I exited from Create, that was sort of the thing we were trying to figure out was, how do we sort out this cooling, to be able to, because we were able to kick out even more material than we were. We just couldn't cool it back down quick enough.
I think that's one of the craziest things, Jeff, is when you first introduced that 3mm nozzle and you had the 1.75mm filament. I was like, what in the world? How in the world can you do that? And I think this is a great segue into just talking about how you actually did that, how maybe even just sharing some of those initial sockets that you did, and then what you did with slicing, because that really, I think, set the course for, even a lot of the thought around how FDM sockets are made today.
Yeah. So, I guess the short answer, how do you do that? How do you do something, 1.75 and make it go into a nozzle that's 3mm and have it function? And the answer is back pressure. What you have to do is you have to have, kind of continuous printing, and you have to have, a certain amount of back pressure pushed back on the nozzle to then, to keep the filament in the nozzle, but also spread it out. So even though we had a 3mm nozzle, we were actually printing something 4.5 millimeters thick. And so what happened is the nozzle actually had a flat tip, and it would act kind of like a spatula. So you just sort of kick out a lot of material. It would, hit the last print, spread out, and then the nozzle itself would flatten it out, even it out, and then they would just sort of go around and around. And so we were utilizing base mode and being able to, just kind of constantly build up in a circular manner, in base mode. But then, also played with kind of, all right, well, can we do this with 2 layers, and just sort of, have a kind of a crossing seam built into it. So, if I guess in the sense you could get, 9 millimeters thick if you wanted to, that setup, because it would be, an outer loop cross to the inner, go around, cross to the outer, go around, cross to the inner, and you have that kind of double thickness. And so we're just sort of playing with things like that, and then trying to figure out how to seal off the bottom as well, which, that involves some kind of interesting patterns that we sort of built in, and then let the slicer do its magic to be able to create what we wanted out of it.
Okay, that's all fascinating, because I think it's really interesting that, not even thinking about speed, I at one point was working on a thing where we were looking at just flattening out these layers in order to get more control over the layer and get better layer adhesion, right? Just to get a stronger part. Was that also important for you guys, or were you just looking at let's make this thing go fast as we can?
Oh no, definitely strong. And actually, the last aspect is clarity. Because a lot of these check sockets you want to see through. So one of the things I did there was just to keep the layer height relatively low. I mean, I was only running a 0.3 millimeter layer height, even though we had that massive nozzle. And so I think did the combination of a couple things. A is spread it out, evened it out, but also just somewhat penetrated that heat and pressure, down into the last layer, the previous layer, to get a little bit more isotropic, bonding.
I think it's really exciting that you guys are able to engineer something that I think everybody kind of knew. If you're trying to stick layers together, you're going to think about increasing the surface area and controlling that, and controlling the thickness, and trying to make that layer cool in a kind of in a relatively kind of organized way. But I think you'd be surprised at just how many people weren't really actually, changing the core variables of FDM. They were just going with what everybody else is doing.
Yeah, and I mean, I just got to credit with building that relationship with Brooke Drum at Printerbot, and then him introducing me to Carl Ubis, and being able to work with him, and I think Carl's still selling some of these things, on his website, that the high flow nozzles and stuff like that. So it's but now there's other companies kind of taking the work that he did, and so you can find different high flow setups and different nozzle setups out there in the field.
I think it's a really exciting development. I think it was also in a lot of other areas we were looking at ways of how to make FDM go faster, and not necessarily. And people were doing sequential nozzling, so what you were doing, but then a little bit different, one after the other, immediately after the other, and stuff like that. But it wasn't necessarily it wasn't necessarily this high flow concept. Is I think really important, a really important way forward now. So it's great that you guys made this happen to show everyone else that this is a really viable path.
Yeah, well, I think it sort of stemmed from we just had a different need, because everyone else was looking for high speed precision, and we needed to build these big shapes quickly. So, and we could sacrifice a certain level of precision.
Yeah, definitely. And now, okay, so now you said now you're doing a bunch of charity work, right? So are you really not, what kind of printers do you use now? Do you really not change them in any way, or are you kind of hacking these things as well?
Let me put it this way. I have 2 mainstay printers that I use kind of on a daily basis these days. One of them's hacked and one of them's not. And, the one that's not is specifically not, because I want it to be as generic as possible. So I mean, it's got a 0.4 nozzle, and mostly what I'm printing on is PLA. So that one's a Creality Ender 6. I really like the Core XY, with that, the speed of that, and the nice kind of nice contained box to it. But I think the last one I bought, I paid $509. So they're inexpensive and pretty solidly built machines. And then the one that I've hacked is actually a Creality Ender 5 Plus. And really all I've done is added micro Swiss direct drive to that, and using their nozzle and hot end and everything.
And
So
is that because of flexible filaments, or is that why did you do that specifically?
Yes, flexible filaments was the main reason. But I've also just been kind of working with increasing the nozzle size on that machine. But yeah, I mean, obviously, direct drive is, it's just critical for the flexible filaments. So that was the main reason.
Yeah, by the way, for the non-3D printing function, you have a normal drive actually pushes a filament, a wire, a plastic wire, either to a tube or not through a tube. And of course, pushing a flexible plastic wire is very, very difficult because it's soft and then it goes all over the place if there's an obstruction. So a direct drive actually pulls the wire, which huge innovation. We were blown away when that happened. And that just makes it a lot easier. And Core XY, by the way, is a different architecture that basically is a new way. Well, you have different ways of moving printers, and either like on the printer bots, the build platform maybe moves in a certain XY way, or the top motion stage moves in a certain way, and then Core XY is a new way of driving printers, which drives most of its motion from a belt drive setup that is really good at achieving very high speeds, but may need more maintenance and may be unstable at really large parts. That's kind of the downside generally. I don't know if you'd agree with that, Jeff, but it's kind of generally, I think. But I am excited about Core XY, I think, as everyone else is.
Yeah. I mean, I wouldn't put a big high flow nozzle on a Core XY because it just won't. It's not as rigid of a gantry, let's say. Somewhat by design because it's sort of that complex belt drive instead of I mean, in some ways, I really like what Filament Innovations have done is that they just got rid of belts altogether. They said made something really stiff, and then they did ball screws. You know what I mean? And that's that's a way to make sure that you can that gantry is not going to move. You're going to be able to really kick out a lot of material, and that 3D printed filament is not going to move that gantry. It's going to go where you tell it to go.
I think it's interesting to know that that a lot of the high temperature printer guys who were trying to make nozzles of 420 degrees plus and chambers of 200 degrees plus, or 200 Celsius. They guys also moved towards kind of like screw based or ball and screw based kind of motion control system because it keeps the heat out of the chamber. And of course, these belts near the chamber is also not a good idea at all, because they won't withstand the heat. So it's an interesting architecture for different reasons. And I think initially, of course, we weren't going to do it because the printer was like $200, and now if you're getting printers that are more expensive, to have that ultra stable build platform is kind of a very interesting. It's a very interesting development to see. Some of them, I've seen printers with 4 of these ball screws on the build platform. When I think 3 would be enough, and maybe even 2. But I think it's a really interesting way to set up your printer.
Yeah, absolutely. Hey, by the way, one more thing to mention about the flexible filaments is that if you want your best setup is do direct drive with like gear engagement on the driver and 2.85 filament. I mean, it just sort of goes back to that concept of pushing a rope. You're pushing something flexible. Well, if it's wide, the wider it is, the less likely it's going to bend. And I at one point I got up to, I think, 100 millimeters per second that I was printing out of flexible filament. I mean, I was printing faster out of flexible than I could out of rigid materials. Just once again, the cooling became the problem. But if you get it set up right, you can there's no binding or anything. It'll just go and flow like crazy.
Jeff, on the speaking of materials and such, and just kind of what are you able to share? Because a lot of people that listen haven't got into 3D printing. They may be scanning, but they may not be 3D printing. So, any suggestions on materials? What you're using in the past, what you're using now, what you think is coming down the pike, maybe if it's something that you can share, and then maybe share a little bit about, FDM and definitive sockets as well. What your thoughts are on that?
So when you say materials, are you talking scanning materials or printing materials?
Printing materials. And you mentioned that you're using some PLA, some flexibles, and things like that. Just wondering if you'd share, with our audience what kind of materials you are using, whether name brand or not, whatever you're comfortable with, and just say some of the characteristics that you look for or that you like.
Yeah, I mean, so once again, it's funny, in my most recent time, it's been focusing on these, what could be done in low income countries. And so I'm kind of specifically not trying to go into real exotic materials. However, with that said, and obviously I have experience with TPUs and I've been using a lot of that Verisure, not so much for the developing world, but I really like that Verisure material on the kind of the foaming TPU. But I guess when it comes to going back to, low income countries, what I really appreciate is the polypropylene. Because a few different reasons. One is that it actually, bonds quite nicely together. So you get, much better Z bonding than other materials. And then the other thing is that materials management. I have some polypropylene that is 6 years old. I have it just sitting on a dusty shelf, not protected at all. And every once in a while, I pull it out and try to print with it, and it goes perfectly fine. I live in there's humidity around here. It's not a dry environment, and it's in a dusty lab. But like it's just kind of amazing that you get good quality, consistent prints out of polypropylene, and not have to deal with all the other materials management. As PETG or TPU, is really affected by moisture. PLA is also affected by moisture, but not as much as the other two. Polypropylene seems to be minimally affected, if at all. The one big drawback to that one is that just getting it to bond to a plate. And sometimes what I do is literally just grab a piece of like polypropylene or copoly, from the lab, a sheet of that, and kind of glue or bolt it down to the build plate and build onto a sheet of plastic.
I'm a huge polypropylene fan as well, also because it's soft and it's really wearable. Do you find that as well, that it's really better than a lot of other things in making it like wearable things on the skin or near the skin, that kind of stuff?
Yeah, that's where yes, it does have that kind of built-in give to it. For people in our field, it's almost they call it polypropylene. I almost want to say most of the polypropylenes I've dealt with feel like a modified PE. You know what I mean? So they're definitely much more of it's definitely much more of a copoly. But I'm kind of finding that there is sort of a spread of how stiff it is, and when you go kind of brand to brand. So, but yes, in general, I do like it. I very much like that bonding, and what the actual characteristics that you get sort of depends on the brand that you buy.
Yeah, no, totally. They're all different. And you mentioned so what are you exactly doing for developing countries and OM people? What's your project exactly?
Yeah, so I have, one project that I've been working pretty intensely on for several years, where we were 3D printing molds to be able to make silicone liners. So, and that's kind of our biggest project, let's say, where by design, I sort of have these CAD designs worked up for being able to make the mold. Once again, the thought process here would be that you can more or less email the file to someone in another country, and then they could use whatever printer they had to be able to print it, as long as it had a big enough build volume. And that's why I've been working a lot with these PLAs and very basic unmodified printers. And so you print up these molds. We do have to get them the medical grade silicone. But even that, we can kind of import it into a country, and it has a 2-year shelf life, and they don't have to inventory each size of liner. That it could just sort of sit in a raw material and get used as needed. And so, really, what we're trying to do is remove the barrier for in low income countries to be able to use silicone liners. Because in a lot of places they're back used doing PTB sockets, with like a sock fit, because they, it's prohibitively expensive. We actually recently did a survey, and the average price in these low income countries for a liner is $350, which I know for like probably the people in the U.S. you can be like, oh, I could get a liner a lot cheaper than that. Well, that's true, but you got to realize that they have to deal with shipping and customs as well. And it more or less doubles the cost, and sometimes makes like 6 months to get a liner into a country. So that's really been a tremendous bottleneck on the ability to improve prosthetic care in low income countries.
I love the idea of like combining molding and printing to just make the entire process easier and doable. Like, give them every size and print it. I love the idea of just being able to make 100 molds maybe, and that'll be enough to treat almost everyone, and then making that whole process cheaper.
Well, the other thing that I love, Joris, is the idea of just shipping in the raw materials, where you kind of bypass all the bottlenecks, right? How cool is it that they're printing their own stuff out of raw material? You're shipping this raw material silicone in, and then they're also making it and then putting it into a finished product. And it's just creating not only better outcomes, but accessibility for these devices at a much lower cost.
Yeah, and I would say the last piece of that is that we're also creating jobs. We're making it so that people, there. Even though the labor rates are much lower there, but like $2 an hour in some of these countries is actually a very good wage. And so now someone's working and supporting their family. So I've been pretty pleased with the whole process. It's been a lot of figuring out things out and learning the challenges of doing this in those countries. But I've had excellent support from multiple universities. Baylor University's worked with us, University of Washington, Northwestern, Imperial College London. Imperial College London is currently doing an outcome study in Nepal of our liners, and really, really excited about, after we kind of finish documenting the process and get this kind of outcome information, then being able to provide that worldwide.
I think that would be really exciting. And what do you hope to achieve with this? Do you hope to just because the idea is you can do this by yourself, or do you hope to really train a lot of people to do this alongside and really spread it like that? Or how do you hope to spread this around a little bit?
Absolutely. We more or less want to help teach individual hospitals or even organizations within each country to be able to do this themselves. So we sort of provide them the knowledge, the tools, the raw silicone, and then they would make their own liners, with our sort of system.
And can you tell us a little bit? Do you have a name for this? Is there a website I can go to for the people who are listening that can want to engage with this?
Yeah, so Operation Namaste. So the website is operationnamaste.org, and we call this our Namaste Limb Solutions. Is the explanation of the kind of the kit. We have information on the website. Okay,
well, Jeff, thank you so much. I think it's been really inspiring. I think what you've done so far already. So all the innovation you brought to bear and all the things you've done, and it's really inspiring to what you're working on right now as well.
Yeah, and right now we have kind of another project brewing. Let's say this sort of stemmed from a request, from a hospital back in Nepal, and we've been sort of quietly working on this for a couple years, but definitely going to be implementing it in Nepal, and may also be implementing this in Ukraine in the near future. Sort of figuring that out. But what I'm kind of alluding to here is we've sort of developed this kit, which is sort of just imagine kind of like a big trunk that has kind of all the tools you need to be able to fabricate a transtibial socket, and including a 3D printer. And in short, you'd have these kits that are become kind of mobile labs that could go into either conflict zones. And we are working with a few different organizations trying to, we need strong partners on the ground if we're ever going to enter into Ukraine. But I already have partners in Nepal where there it's more of a, they're looking at kind of rural healthcare. So, they one of the hospitals we work with, they have kind of a main hospital, but they also go out, across the country, and they sort of set up in health centers and provide, either the orthopedic surgeries do kind of light surgery, the physical therapists do therapies, the orthotists do club foot bracing, but there's been a great desire to do prosthetics as well. And so this makes it so that they can make these more rudimentary transtibial prosthetics without having to require the patient to travel all the way across the country to get to their hospital. So that's sort of something we've been working on for years. The main thing that we've been working on is the software side, because we knew that we needed a really good software before we could actually develop the hardware. But in October of this year in Nepal, we'll be kind of implementing the bringing up the first limb kit, complete new version, let's say, of the limb kit into the country to be able to start doing that rural care. And as I already said, we've been talking with some organizations to be able to do something similar in Ukraine.
That sounds very, very exciting, Jeff. That's great idea. And I think you enjoyed it too, right, Brent?
Oh man, this was great, and it was great to hear kind of the heartbeat behind it, and all the adaptive stuff. I didn't realize all that too. So that's very cool, Jeff.
And thanks, Jeff. Thank you so much, and thank you for listening. This is another episode of the Orthotics and Prosthetics podcast. I'm Joris, and we were with Brent, Wright, and Jeff today. And thanks a lot for being a part of this. Have a great day.